Hey everyone, welcome back to another video on Apache Ignite. In this video, we will learn about distributed data structures. We will understand what is a distributed data structure and how can we use Ignite to implement distributed data structures in an application. So let's try to understand what is a distributed data structure. Suppose we have a Java application which is running. So we have a running JVM, and you can also say this is instance I1 of that application. And in this application, we created a collection. This collection can be a hash map, an array list, a set, whatever it is. It is a collection that will store some data, that will store some elements. So we know when we create any collection, it will be stored as a Java object on the heap. And depending on how we have written the code, any piece of code can access this particular collection to, let's say, add some items, and some other code can access this collection to get the items. So that is how we generally write collections in a Java program. Now, suppose at any point of time, this collection has two elements, E1 and E2. And we run another instance of the same Java program. That means we have another running JVM, and this is instance I2. Now, what will be your answer if I ask you a question that if this collection will be accessible to I2, any piece of code which is running in I2, can that piece of code access this same collection? Can a piece of code running in I2 put some values in this collection, or can it get the values from this collection? Of course, the answer is going to be no. Why? Because this collection is local to this particular instance, which is I1, and this collection is stored on the Java heap of instance I1. Similarly, whatever collection we create in I2 will not be accessible to instance I1, because all these collections are local to that instance, local to that Java process, because each Java process has its own instance of JVM. So they have their own Java heap memories. Any object that we create will be on the heap memory of that instance. So these collections are local to that Java program, local to that instance. These are not distributed data structures. These are not distributed collections. So that's what we mean by distributed data structures. So let's see how a distributed data structure will look like. In case of distributed data structure, we can have multiple nodes or multiple instances of same Java program. So let's say this is I1 and this is I2. And when we create the distributed data structure, this data structure will be shared between I1 and I2 or any other node if it is available in the cluster. So that means when we create the distributed data structure, it is accessible to I1, it is accessible to I2 as well. And both the instances can get the items from this collection as well, because this collection is not local to a particular instance, but it is shared, it is distributed. And notice one thing, in case of distributed data structure, whatever entries are being stored in the collection are accessible to any node. So let's say if I1 stores the entry K1 and V1, I2 can read the data by key K1 and it will get the value V1, because this entry is stored on the collection and this collection is accessible to I2. All right, so that is the purpose of distributed data structure, so that we can have a common, let's say, collection that can be reused across the cluster. Now let's talk about the use case. When should we use a distributed data structure? We can use a distributed data structure, for example, a queue, to implement a load balancing solution. Let's say we have a cluster of 3 nodes. So these nodes belong to the same Java application. Now what would happen? The client will submit the requests to get some work done, and client can submit the request to any node. So the request can come here, another request can come here, or third request can come to this node. But what happens when some of the nodes accept more traffic than the others? So let's say this node is overloaded. There are multiple requests on this node. So in this case, this node is going to be overloaded while these two nodes are relatively free. How can we solve this problem? Well, we can use distributed queue in this case to balance the load. We can have a distributed queue like this, and we can implement a solution that whenever a node accepts a request, it can simply enqueue that request in the distributed queue. Then any node who is available, who is free, can pick the item from the distributed queue. It can start the processing. So in this way, no matter how many requests are landing on a particular instance, all the requests will be added to the distributed queue, and the nodes, depending on their bandwidth, will pick the item from the queue in order to process them. So that can be one use case of distributed queue. We will now see a hands-on example on distributed queue that we can implement using Apache Ignite. Let's move on. So here I will create a new branch from the master, and in this branch we will implement the distributed data structure, specifically a distributed queue. Let me create a new branch from the master, and we will name it distributed data structures. And now we have the simple setup in which we have a cache. Although we don't need the cache, so let me clean the code. We don't need the cache here, and so we can comment everything, or even better, we can remove everything. So let me remove the data region configuration and the cache configuration. We don't need to enable the native persistence, so I can remove this code as well, and the configuration part. Now this code is much cleaner. In this code, we are simply initializing the ignite using ignition.start method. And in this bean method, we have access to that ignite object. So once we have the ignite object, we can create a distributed data structure. There are several data structures supported like set and queue, countdown, latch. We are going to use queue. How do we create a queue? Well, we use the ignite object. So we say ignite dot, and here is this method queue. So there are three parameters, accepted parameters. The first one is a string, which is the name of the queue. Let's say we give it a name, work queue. The second parameter is the capacity of this queue. We can pass it 0. That means this is going to be an unbounded queue. And the third parameter is an object of collection configuration. So we can pass an empty collection configuration. And this will return an ignite queue. Let's verify the return type. This is going to be ignite queue. And we can store it. We can provide a type parameter that is going to be string. And we can name it work queue as well. And we need to import it like this. So before we start working with the queue, let's spend some time on the collection configuration. We have seen other configurations like data region configurations and cache configuration. And in the same way, we also have this collection configuration. We can use this configuration object to set some properties of this collection, in this case, this distributed queue. So for example, we can set the backups. We can set if this collection is going to be co-located collection. We can set the atomicity mode and so on. That's the use of this collection configuration. I'm not going to use this, and that's why we have passed an empty object here, collection configuration. That means it's going to be default settings. Once we have the queue object, we can use this queue same as any other queue, same as any other blocking queue or Java queue that we are already aware of. So if we check the methods, we have methods like put. Put is generally the blocking call. That means it will try to put an item in the queue. And similarly, we have other blocking methods like take. So these all methods are supported same as any other queue. Put, take, add, is it bounded, clear, close, and all that. Now the thing is, how are we going to use it? So before that, because we will be running at least 2 instances to showcase the distributed data structure in the same way, same as the previous video, let me write this method which node to identify which node it is running right now. And we will pass the node parameter as a VM argument. So that is going to be system.get property, and the name of the property is switch node. What I want to do is, let's say when we have the node 1 running like this, so when we have the node 1 running, we want to put this node 1 to sleep for, let's say, 30 seconds. And after sleeping 30 seconds, we will add some item, a couple of items in this queue. So stream.off, let's say A and B, and then we will say lm work queue dot put lm, like this. All right. Else, if this is node 2, then what we want to do, while true, we want to run node 2 indefinitely to get the items from the queue. So while true, we want to take the item from the queue. We will say item work queue dot take. It's going to be a blocking call, and we will print the item in the logs. So let's see what we are trying to achieve here. We will run two instances, and we are saying if this is node 1, then sleep for 30 seconds. And after sleeping for 30 seconds, put two items in the queue. We want to introduce this delay so that when we run node 2, we want to see node 2 getting blocked at this point while taking the item from the queue. So because node 1 will be sleeping for 30 seconds, there is nothing in the queue. When there is nothing in the queue, take method will block for some items to be available in the queue. So we will see node 2 blocked here. And after 30 seconds, when node 1 puts these two items in the queue, we will see node 2 getting unblocked, and we will see the items in the log messages. So let's start the node 1 first, and we can start second node as well, because second node is going to wait while taking the item from the queue anyway, because there is nothing in the queue. So we can start both the instances simultaneously. This is node 1, and this is node 2. So you see both the nodes are up and running, but we don't see this log message. And the reason is node 1 is still sleeping. Once node 1 is out of sleep and puts the elements in the queue, then only node 2 will be able to proceed, and we will see the messages in the console. And so after 30 seconds, now we see the messages on the console that item equals to A and item equals to B. So this was a very simple example to showcase how to implement distributed data structures, how to use distributed data structures in the real life. We can have many nodes in the cluster. We can have different data structures, sets, queues, countdown latch, and whatnot, whatever is available in the Apache Ignite. But the fundamental approach remains the same. We create a data structure which is shared across the cluster among all the nodes, and then different processes, different nodes can use their data structure to, let's say, put some data while other node will try to fetch the data. So that was a small video on Ignite data structures. I hope you liked this one, and I will see you in the next video. That's all for now. Thanks for watching.